Hello everyone. Now we are going to discuss electric circuits. Okay. This electric circuit means connection of all electrical components, all electrical components with the closed circuit. Okay, with the copper wire we have connected the components. Here consumer and a source and a switch. Then we use ammeter or voltmeter and so and so, so and so. If a number of then all equipments we can able to connect in a closed circuit, right? So this electric circuit means it shows the path of flow of electrons. Electric circuit can show us the path of the flow of free charges. Okay, right. These electric circuits are two types. So we are going to discuss two types of circuits. In the first one, series connection. Series connection of resistors. Series connection of resistors. Okay, yesterday we discussed that in the Ohm's law. Resistor, then resistance. Yesterday we discussed Ohm's law, V equal to IR, right? Here R means resistance. What is resistance? Opposing of flow of charges. Resistance means very simple manner we can say that opposing of flow of charges is called as resistance. What is resistance? The material which is resist the flow of charges is called as resistor. Okay, opposing of flow of free charges are called as resistance. The nature, opposing nature which is exhibited by the conductor is called as resistance. The nature is called resistance. Which are resisting, those are called as resistors. So here iron is a resistor. Iron is a conductor. The flow of charges can travel, the charges can flow, but it can resist. Okay, such way. So resistors means which are resistors. Okay, we have discussed it. For example, if we can take a silver, copper, iron. In our last class we have discussed that three different materials. The resistance of a conductor is depends on nature of the material. Out of these three, silver has low resistance. Out of these three, iron has high resistance. That means, sir, the electrons, the free charges are not travel through the iron. No. Yes, the charges can travel, but opposing nature little bit greater than the copper or silver. So here this is good conductor. So, but in the electric circuits, we use copper itself. We use copper. Actually, silver is having the low resistance. But we are using the copper circuits. In our household electric circuit, we are using copper. Why? Because silver is the costliest one. Very simple thing. Okay, is this is right? Okay, like the resistor means then which is opposed the flow of free charges. The nature of flow of the opposing nature of flow of free charges is called as resistance, which are opposing is called as resistor. Okay, right. So here series connection of resistors. Sir, how we can connect sir all resistors? Here the symbol of resistance. Symbol of resistor is this. Okay. One resistor. I have taken 3 resistors and 3 are connected to a single wire. See here? This kind of connection is called as series connection. Alright? And this is connected to a copper wire and a battery and a switch and a ammeter like this. Okay, this is the one circuit. This is closed circuit. See, all the three resistors are connected to a single path, right? So here the current I can travels from this resistor, from first resistor and the second resistor. This resistance is taken as R1 and this is taken as R2 and this is taken as R3. How much current can travel through this circuit R1 sir? Means how much current is traveling from the conductor. Same I current is travel from the R1. Same current and same current. Alright? So, flowing of current can be same. So, same amount of, we have arranged the resistor, the amount of current which is traveling same. Such kind of connection is called a series connection. Okay, right. Then after, what's about the potential difference sir? The potential difference is, we have arranged the resistor and it is given V1, V2 and V3. V1, V2 and V3. Okay, these are the resistors. So which are constants are here? Here current is constant. That means how much? I is the current. Okay? Right. What's about the resistors sir? Resistance of a resistors equal to R1, R2 and R3. R1, R2 and R3. What's about the potential difference? PDs of resistors. With R1's resistance, potential difference is V1 and R2's is V2 and R2's is V3. So here we have current and a resistor, resistances and a potential difference. So here we have to find the effective resistance. equal to how much, sir? Here we have to find what is the effective resistance here. That we are going to find. How we can find, sir? Here we know the potential difference, resistance and I. We have one relation between potential difference, resistance and I. What is that? Ohm's law is given that V equal to IR. This is the principle. This is the result. V equal to IR. Use this principle for all. Here what is the potential difference? V1. Here V1 equal to IR1. Right? And V2 equal to IR2. V3 equal to IR3. V1 equal to IR1, V2 equal to IR3, V2 equal to I. Isn't it? I. Here I is constant, no? Right? Potential differences are different. And here we know that. So what is the total potential difference? This total equal to V. That means V equal to V1 plus V2 plus V3. Potential difference of R1 is V1, R2 is V2, R3 is V3. But overall potential difference of all the three resistors, that becomes V. How much is that? That equal to potential V1 plus V2 plus V3. Sum of all the three resistors potential difference equal to total resistance, total potential difference. See, V equal to V1 plus V2 plus V3. Right, got it? Here we know that V equal to IR. V1 equal to IR1. Here IR2, IR3, IR1, IR2, IR3. Sir, here I is common now. So IR equal to I is common. So R1 plus R2 plus R3, sir. So I gets cancelled. Therefore, effective resistance or effective equal to R1 plus R2 plus R3. This is called effective resistance. So that means what is the resistance? Effective total resistance of the series connections that is equal to sum of the all the three resistors. This is the way we can find the resistance of a circuit. So here, for example, in a given question, you will get question like this. Three resistors are connected in series. So one is 3 ohm, one is 5 ohm, one is 7 ohm. Find the effective resistor. How we can find, sir? This becomes R1. R1 equal to 3 ohms. This you can take it as R2 equal to 5 ohms. This taken as R3 equal to 7 ohms. So how we can, this is series connection or not? See here, amount of current is traveling the same now, right? So that's equal to, or effective resistance of a series connection equal to R1 plus R2 plus R3. This is the principle now. So R equal to R1 equal to 3 plus 5 plus 7. So R equal to 10, 15. How much? 15 ohms. So here the effective resistance of a series connection is sum of the individual resistance of a resistors. Sum of all the resistances. That is equal to or effective. Got it? This is a way to find, you will get the problems to find the effective resistance in a given series connection. Okay? Right. This is one type of a connection, series connection. So what is, with this connection, we have one drawback. If any circuit is breakdowns, if your circuit is disconnected. Remaining resistors will work? No. This kind of circuit, series connection, we use in series bulbs, decoration bulbs, which we can use to decorate the houses. These all are series connections. So if connection is breakdown, if one between, then series connection, series lights contains hundreds of thousands of bulbs. If any one bulb is fails, then remaining total circuit can disconnect. That is the drawback of this series connection. Okay, right. So now next, one more type of connection. You may get 2 more questions in 10th class point of view by using this principle. Is this okay, right. Next, parallel connection. Next one is parallel connection. Connection of resistors. Parallel connection of resistors. Next one. Here, in the previous case, we have arranged the resistors all in a series. Now, how parallel connection can takes place? Now we are going to do. This is one resistor. One more resistor. See? This is a way of connection of resistors. See here, R1, R2, R3. 3 resistors are connected to one end and remaining 3 are connected to one end. This is connected to a battery or a cell and switch. This is a way to arranging of resistors. Okay, right. Here, what's about the current cell? Here, current I. In a previous in series connection, all are connected to a one port. No, so I is equal in all the 3 circuit, all the 3 resistors. Here, what happens when current is reaches to here, it has 3 ports. One is this direction, this direction, this direction. What happened to the current when it is comes here? The current is splits. The amount of current which is came to here, it is traveled to here, that can be splits in a 3 resistors. Then here, for example, ammeter A1. That means you can take it as I1, I2, I3. So what happened? Current is splits here, and here it comes in this. Again, how much current, sir? Here, how much current is traveling here? It comes here. This can be takes place in the parallel connection. Understood or not? Current is travel in this way, and after it splits. Okay, here then when current is comes here, it can splits. For example, like this. If then some persons, 100 persons are traveling on this road. and your load is splits into three different ways here. Okay, right, 100 persons are came up to here. So what happened is, this is the way is narrowed now. So the persons have three different ways. What happened out of this 100%? Some are can travel in this direction, some are can travel in this direction, some are can travel in this direction. They can splits. Like your current also. That current when is travel up to here this current is get three different paths, three different routes to travel. So what happened? Your amount of current is splits in different parts. Here also current is splits. And again these three are connected to one end itself. And again all the three are connected to one end. What happened? Again these all are then again they all come in the same way. No? So again here how much? 100%. Like that. Here how much current is traveled? The some amount of current is reached to these three resistors. Then here it has three separate parts. No? Then the current is splits here, and again it combines with travel. Okay, this can be takes place in as a parallel connection. So what's about the potential difference? What's about the potential difference? Here potential difference is at 2 points is V. So here which is constant, sir? Potential difference is constant V. Here potential difference is constant. Sir, what's about the current, sir? Current equal to I1, I2 and I3. What's about the resistance, sir? Resistance of three resistors becomes R1, R2 and R3. Okay. Then here amount of current I equal to your current is splits. Right? Here I amount of current is came out. Then here at this part the current is splits becomes splits into I1, I2, I3. Then how much current is comes out, sir? This current is equal to sum of these three currents, no? Right? So I equal to I1 plus I2 plus I3. Here in this example, 100 persons are came to these three different ways. So these three are enters into three different paths and they came here. How many persons are came here? Means the sum of the persons from this way 40 members, from this way 20 members, from this way 40 members. So how we can calculate how many members are enters into the another way? That can be calculated by sum of the persons from the three different ways. Then 40 plus 20 plus 40, that is equal to 100. Like that here, the amount of current, how we can calculate, sir? That is I equal to I1 plus I2 plus I3. I equal to I1 plus I2 plus I3 is this is a way. Right? And again here we got R1, R2, R3, sorry. I, R and V. We know the relation, very simple, V equal to IR. Sir, here I1, here current is splits. Now how much current is traveled through this circuit? From this, how much current is traveled from this resistor? How much current is traveled from this resistor? Sir, how we can find? By using this principle itself. Right? That means I equal to V by R. From the Ohm's law, we can calculate that V equal to IR. From V equal to IR, we can get this equation I equal to V by R. This can be applicable in all the three resistors. Then I1 equal to V by R1, right? I2 equal to V by R2 and I3 equal to V by R3. Sir, why? V is constant here. Right? Okay. Then Sir, here we have an effective, here we have to find effective resistance, and here we know one hint. Sir, current, this I equal to, here I equal to I1 plus I2 plus I3, here I equal to I1 plus I2 plus I. Same amount of current only splits here, no extra current is created there, right? So by this we can calculate that I equal to I1 plus I2 plus I3. From that, so I equal to V by R. V by R equal to, right, V by R1 instead of I1. I1 equal to V by R1 instead of I2. V by R2 plus V by R3. Here V is common, 1 by R, that's equal to V is common, 1 by R1 plus 1 by R2 plus and 1 by R3. Here potential difference is same. So V is gets cancelled. That means 1 by R equal to 1 by R1 plus and 1 by R2 plus 1 by R3. This is the principle. This is the equation to find the effective resistance of a resistors when they are connected in parallel in connection. When they are connected in parallel in connection, that is 1 by R effective equal to 1 by R1 plus 1 by R2 plus 1 by R3. Right? Here one example. See how two resistors are connected in parallel connection. Okay, like this. And here we have given 2 ohms and 3 ohms. Resistance of first resistor is 2 ohms and the second resistor is 3 ohms. Then how we can find the effective resistance of this circuit? This is the principle. 1 by R equal to 1 by R1 plus 1 by R2. Then here you can consider as R1, this you can consider as R2. So 1 by R equal to 1 by R1 equal to 2 plus 3. Alright. So what is the LCM, sir? 2 3 is 6 is the LCM. 2 3 is 6, 3 2 is 6. Then 1 by R equal to 5 by 6. Therefore R effective equal to 6 by 5. Yes, this is 6 by 5 ohms. So how much we will get, sir? Approximately R equal to 6 by 5, no? 1 and 1.2 ohms. Right? 1.2 ohms. And here you see that effective resistance is 1.2 ohms. But individual resistance is 2 ohms and 3 ohms. In case of series connection, effective resistance is greater than their individual resistors. That means effective resistance in a series connection is greater than the individual resistors in series connection. Okay, what we have discussed now, one is 2 ohms, one is 3 ohms, one is 4 ohms. So and this is series connection, then 2 plus 3, 5 plus 3, 9 ohms. See, 9 ohms is the effective resistance of series connection. So 9 is greater than their individual resistors, no. Here you can see effective resistance in a series connection is 1.2. This is less than the individual resistors. So always we will get the effective resistance of a resistors when they are in series connection is less than the lower resistance of a given resistor, a given circuit. Here out here 2 resistors are given, no. In that one is 2 ohms, one is 3 ohms. Which is lower one? 2 ohms. So effective resistance we will get lower than the less than the lower resistor which we use in the given circuit, which we use in a given circuit. Not only that, this principle we can use 1 by R equal to 1 by R1 plus R2, or otherwise we can use like this also. Okay, right? R equal to R1 R2 by R1 plus R2 is in this way also we can we can use this principle. Okay, so I will give you, if I will use this principle, see, R equal to R1 equal to 2 into 3 by 2 plus 3, R equal to 3 is 6 by 5, so R equal to 1.2 ohms. See, both are same or not, so either we use this or this. Okay, 1 by R equal to R1 plus R2 and so and so, or R equal to R1 by R2 by R1 plus R2. If this is the way to, we can find the effective resistance of a resistors. Okay, so I have given how to find the equation of effective resistance when the resistors are connected in a series connection and as well as in parallel connection. Here I will give you one more example, then you may get the problems in this way also. Circuit, he will give the circuit for 2 marks. Right. Okay, here this is given as 4 ohms and this is given as 12 ohms and this is given as 6 ohms. Find the effective, you will get the question like this, find the effective resistance of this given circuit, right? Just before I said one example which is related to only series connection and one more example which is related to only parallel connection, but here sir, parallel and one common, parallel connection and one more resistor is there. Sir, how can we find out, sir? Means in such cases, first of all we have to find out whether resistors are in parallel connection. We should find the resistors which are in the parallel connection, effective resistance of a resistors which are present in parallel connection. So these two are in parallel connection now. So I will consider this as a R1 and R2 and R3. So here now I am going to find the effective resistance of this parallel connection. Okay, so I will use this principle, R effective of parallel. So I will keep like this RP, that means parallel connections. So what is the principle? R1 R2 by R1 plus R2. Either otherwise you can use 1 by R equal to 1 by R1 plus 1 by R2. Right? Whatever it may be. So here I am using this one. So RP. P means parallel connection. Here 2 are there, no? So further. So effective resistance of parallel connection. R1 R2. R1 equal to 4 ohms into R2 equal to 12 ohms by R1 equal to 4 and R2 equal to 12. Okay, R1 equal to 4, R2 equal to 12, R1 equal to 4 plus 12. So that's equal to 12 4 ja 48 by 4 plus 2 12, 4 plus 12 16 and 16 1 ja 16 3 ja 48. So RP equal to 3 ohms. Right? Here we got the effective resistance of these parallel connection. Now this effective resistance of these two parallel connections and this becomes in series. Now after finding this effective resistance of this parallel connection, this circuit becomes minimized like this. This is 6 ohms, this is 3 ohms. See, from where we get 3 ohms, sir? This is minimized, right? Effective resistance of this parallel connection, we got 3. Our answer is correct or not, sir? Then one point I said just before that, the effective resistance of a parallel connection, always we will get less than the lower resistor which we used in that circuit. Here, which is the lower resistor? 4 ohms. Less than this. So, 3 is less than the 3, no? Right, okay. Now, after this effective resistance becomes a series to this. Got it? So, this connection is minimized like this after finding out. Okay. Now, here these two are in series. So, now R effective of the total circuit is equal to Rp. This is what? Rp. This is R3. Okay, Rp plus R3. So, R effective equal to P equal to 3 plus 6 and R effective equal to 9 ohms. So, this is the way to find the effective resistance when a given circuit is given a little bit complicated one. Okay, most probably you will get the problems. Either he will give only series connection or either he will give only parallel connection. Sometimes he will give for 2 marks, then one series and one extra connection he will give. In such case, first of all, the parallel one you should make it a effective resistance, then the parallel becomes a series to the next one. This is the way to we have to find the effective resistance of a given circuits. Okay, thank you.